Hello everyone, my name is Pichayawee Promsen. Today I will be talking about law of conservation of mass in chapter 7, lesson 2. Consider the head-on collisions of two bad balls to illustrate the conservations of momentum. So we assume that the net external force on this system of the ball is 0. So although the momentum of the two balls changes as the result of the collisions, the sum of their momenta is found to be the same after the collisions. So immediately after the collisions, the ball have different velocity and momentum, so which we designate by the prime on the velocity. So no matter what velocity and masses are, the experiment shows that the total momentum before collisions is the same as afterwards, which we can put in formula of MA/VA plus MB/VB equal to MA/VA prime plus MB/VB prime. And a general statement of the law of conservation of momentum is the total momentum of an isolated system of an object remains constant. So now let's look at this picture of two colliding balls. So the two objects, their momenta before is PA and PB. And after the collisions, the vector of A is negative and V is positive. And also, the collisions after that, the momenta became PA prime and PB prime. So at any moment during the collisions, each exert a force on each equal magnitude but opposite directions. So from what we know is momentum is equal to mass times velocity. So momentum A is equal to mass A times velocity A, and momentum B is equal to mass B times velocity B. So we can use Newton's law of motion, which is Newton's third law, to show that momentum is conserved. So force is equals to momentum over time. So force for B is equals to momentum B over total time. So it's going to be P prime minus B initial over total time. And for force A is equals to momentum A over total time. So it's going to be P prime minus P initial over total time. Then, since there is no external force, so 0 is equals to total momentum B plus total momentum A over total time. So it's going to be P primed minus P initial and PA prime minus PA over total time. So it's going to get P prime B minus P initial B plus PA prime minus PA initial equals to 0, which shows that PA prime plus PB prime equals to PA plus PB, which the conservation of momentum is used. Now let's look at the problem of 20,000 kilo railroad car A traveling at a speed of 25 meters per second strikes an identical car B which is at rest. If the car locks together as a result of the collisions, what is the common speed afterwards? So we know that P initial is equals to MA times VA plus MB times VB equals to MAVA. So we know that the identical car B, which is at rest, so V is equals to 0, and P final is equals to MA plus MB times V prime. So we know that P initial is equals to P final. Then we can equate both equations together as MAVA equals to MA plus MB times V prime. And now we equate both together, so it's gonna be V prime equals to MA over MA plus MB, which is 20,000 over 20,000 plus 20,000 times 25 meters per second. So we're gonna get around 12.5 meters per second. So this is how you use the law of conservation of mass to find such other variables such as velocity.